If I want to talk of y as a function, then this is not acceptable. So we say that, okay, for this to that values only we talk. That is, we fix some value to some value. That's it. Suppose I remove 5 pi by 6. In that case, there would be no choice except this. And now you have got a function. We can use x for this. So generally speaking, we can talk of sine inverse x as a function. How do you plot an inverse function? That we have discussed in functions topic. You draw the line y equal to x. You have the function y equal to fx already plotted. Y equal to fx function is already plotted. You draw the line y equal to x. Take the mirror image of that function y equal to fx, assuming the mirror to be this line y equal to x. That's how you are able to get the plot for inverse function. Now that we are talking of something like this as a function, then comes the question of domain, range. So what values of x are permissible? Can you answer that question? X goes from where to where?
Sir, x goes from -1 to 1.
-1 to 1. And -1 to 1 is closed, both sides. So that is the domain of sine inverse x function. Now regarding y, I said we would fix from certain value to certain value. That's it. We would not go beyond that. So we must ask ourselves that from -1 to 1, every value is covered. So minus pi by 2 to pi by 2 will cover all values from -1 to 1, isn't it? First quadrant and fourth quadrant, sine function will be able to cover all -1 to 1 values, sine function. So when we talk of sine inverse x as a function, then we confine ourselves to minus pi by 2 to pi by 2. That's it. So sine inverse half, will it be 150 degrees? Well, if we talk of function, no. But otherwise, sine 150 is half. But as a function, when we are talking, then we shouldn't be saying that sine inverse half is 150. So what's the answer for sine inverse half?
Sir, it's pi by 6.
Pi by 6. This representation is also made in this manner. Arc sine x. And it never means 1 upon sine x. Would you like to try on the board sine inverse x, plotting sine inverse x? Or maybe I can illustrate sine inverse x. Or if you want, you go ahead. Well, I'm just interested in minus pi by 2 to pi by 2. That's it. So don't cross minus pi by 2, pi by 2. Yes, now you are on the right track. Alright, that's okay. Fine. So it will go like this. So how does one get it? By taking the image method. One just draws sine x. One would just draw sine x minus pi by 2 to pi by 2. Now pi by 2 is roughly 1.5. This is y equal to x line. So if x coordinate is 1.5, y coordinate will be 1.5. But sine 90 is 1. So sine will be below that line. And likewise this side. I have drawn only from minus pi by 2 to pi by 2. Then you take the mirror image. It's a double mirror, by the way. Double reflecting mirror. So the image of this will go here. Image of that will go here. Likewise, you can handle other inverse trigonometric functions as well. Now, for sine inverse, we talked about domain and range. Likewise, we have cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse x. As far as domain is concerned for sec inverse and cosec inverse, x represents what? Sec y equal to x. Value of sec. Value of sec never lies between minus 1 and 1. So x can be anything, but it can never be between minus 1 to 1. X is sec of y. So x is sec of something, and sec of something never lies between minus 1 and 1. Same story for cosec inverse. What do you think should be the domain for cos inverse?
So it's from -1 to 1.
Closed, open?
Closed.
Both sides closed. Now, x is tan of y. So, x can be anything. X is cot of y. It can be anything. All -1 to 1 values are covered. So we should have cos in, we can have cos in first and second quadrant. First and fourth would not work for cos, right? So first and second quadrant if we cover, then it would become 0 to pi. Tan inverse, all values of tan inverse can be covered if you cover first and fourth quadrants. But because of infinity, you will not use closed brackets. Like sine inverse -90 to 90, cosec inverse is same story, but while cosec 90 is 1, cosec -90 is -1. Between these two angles, 0 comes, and cosec 0 is a problem. Cosec 0 is a problem, infinity. So that we must omit. Now, 0 to pi, cos and sec both will cover all values that they have got. But sec of 0, sec of 0 is okay, 1. Sec of pi, okay, -1. But between these two, you have got 90, and sec of 90 is a problem. The last is cot. Now, first and fourth, cot is okay for first and fourth. But still, we prefer to go for 0 to pi. We could have gone for minus 90 to 90, but for minus 90 and 90, 0 will pass, and cot 0 is a problem. If we go for 0 to pi, pi by 2 will come in between, and cot of pi by 2 is okay. Cot of pi by 2 is 0. So if we just say open and open, it's good enough. Cot 0. Now I need to have open for that. Otherwise cot 0 will be a problem. Cot pi also there is need to have open, or that will be a problem. So open for both. So now we have got limited angles to worry about, limited angles. So if I am dealing with sine inverse function, I know I don't have to worry about third quadrant or second quadrant. I just focus on sine inverse first quadrant and fourth quadrant. Cos inverse, I focus on first quadrant, second quadrant. Tan inverse first quadrant, fourth quadrant. Let's now discuss properties. Sine inverse of sine x. That doesn't have to be x. For example, sine inverse of sine 150 degree. That's not 5 pi by 6. Sine inverse function will never be going to third or second quadrant. Right? So sine inverse of sine x is not always x. It is x if x lies in first quadrant or second quadrant, first or fourth quadrant, first quadrant or fourth quadrant. If x lies in first quadrant or fourth quadrant, then sine inverse of sine x is x. Likewise, cos inverse of cos x will be x if x lies in 0 to pi range or first or second quadrants. Tan inverse of tan x will be x if x lies in first or fourth quadrants. Cot inverse of cot x will be x if x lies from 0 to pi, open. Likewise, we can talk of cosec inverse of cosec x and so on. Now, any questions up to this point, let me know. Okay. So answer this simple question. How much is that?
So that's pi by 4.
Pi by 4? And how much is that?
So that's 2 pi by 3 only.
How about this one?
Pi by 3.
This one?
So that's pi by 3.
Pi by 3. Right. So how does one do this problem? You realize that 2 pi by 3 answer doesn't lie in first or fourth quadrants. So you do it like this. Sine inverse of sine 2 pi by 3. Sine 2 pi by 3 is root 3 by 2. Sine inverse root 3 by 2 is pi by 3. Then how about this one? Cos inverse of cos 7 pi by 6
So that's pi by 6.
pi by 6.
Yes, sir.
Can you repeat? Well, can you check?
So that's 5 pi by 6.
5 pi by 6. Then how about this?
So that's minus pi by 3.
Minus pi by 3, yes. Then how about this?
So that's 0.
You're getting 0. Check again. How much is this? How much is this?
So that is 2 pi by 6.
2 pi by 6. Two pi by 6. Are you sure? Or 5 pi by 6?
So 5 pi by 6.
So what's the answer then?
It's -1.
-1. So when we have such situation, we need to be careful. But if it is opposite situation, like sine of sine inverse x, that's a very comfortable situation. Because with sine function, there is no such trouble. So whether you have sine of 30 or sine of 150, you are going to get the same answer. So sine of sine inverse x, cos of cos inverse x, tan of tan inverse x, cosec of cosec inverse x. In all cases, it is x, 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 x. Yes, domain is going to be different. For example, if I'm talking about sine of sine inverse x, then obviously x must lie between -1 and 1. Only then sine inverse x would have a meaning. But if I'm talking of cosec inverse x, then this thing will be meaningful if cosec inverse x is meaningful. And cosec inverse x is meaningful if x does not lie between 1 and 1. -1 and 1. If x does not lie between -1 and 1. So here x must lie between -1 and 1, and here x must not lie between -1 and 1. So their domains may be different, but this is also equal to x, and this is also equal to x. So sine inverse of sine x is more of a problem. Sine inverse of sine x is more of a problem than sine of sine inverse x. Try this.
So that is minus 0.58.
If I heard you correctly, you said minus 0.58. And the answer I have is 3 pi minus 10. So let's see if it is okay. Yes, you got it right. Any questions? Let me know.
No, sir.
Now try this one.
So that is 0.28.
Let me see. .28 you are getting. The answer I have is 2 pi minus 6. So looks like it is all right. Fine. Next, set of properties minus theta basically, or I should say minus x. Sine inverse of minus x. Cos inverse of minus x. These results will work for different domains as applicable here. Minus 1 to 1, x will lie between minus 1 to 1, minus 1 to 1, anything, everything except minus 1 to 1, everything except minus 1 to 1. Let's prove any one of them, and likewise other results can be proved. Let's prove this one. So we are going to prove that sine inverse of minus x is minus sine inverse x if x lies between minus 1 to 1. Okay? The typical method for proving things is let this equal to some theta. So let this is an angle, let this be equal to some theta or y. So obviously minus x will be sine theta from the definition, or x will be minus sine theta. Right side we are dealing with sine function. Sine function has this property. We are free to use that. Now next step is the crucial step. Can I write this? That's a big question. Let's see. We said x was between -1 to 1. So because x is -1 to 1, we are justified in writing sine inverse x equal to minus theta. But one can say, can't theta or minus theta lie in third quadrant or second quadrant? How do we know that minus theta certainly lies in first or fourth quadrant? That's a good question, and the answer to that is we have taken theta as sine inverse of minus x. So it is obvious that theta must be lying between minus 90 to 90. This step, sine inverse function, is defined like that. So if theta lies between minus 90 to 90, minus theta will lie between minus 90 to 90. This step is right. Next. Next, I think we are done. Bringing minus to the left side. And what was theta? Sine inverse of minus x. So whenever you are about to apply sine inverse concept, that is the point you need to reason out. Whether this is applied or this is applied. These are the key steps, generally speaking, because that's where these restrictions come in. Any questions? Let me know. Just like we proved this, we can prove other results. Next group of properties. These three results together make next set of properties. X will be defined in different ways. Cosec inverse x. So here x should be lying like this. Sec inverse should be the same story. This I have already written. Zero, no, because 1 upon 0, we don't want that. So greater than 0 or less than 0. Let's prove this fellow. Others can be proved in similar manner. Same technique. Let something be equal to theta. X equal to cosec theta. I want 1 by x. Now, whenever we take inverse, that's where we have to be very careful. And if we are taking cosec inverse x is theta, then theta is going to lie from where to where? Can you tell me? Theta will lie from where to where?
The theta lies from minus pi by 2 to pi by 2 minus 0.
Except 0. Yes. So if theta is in first, fourth quadrants, then it is okay to write theta equal to sine inverse 1 upon x. Theta in this case should be in first and fourth quadrants. It is in first and fourth quadrants. This is right. But theta is cosec inverse x. Looks like it is done already. Any questions? Let me know. Likewise, we can prove others. This discussion will continue in the next class. We stop now.